right, so we're going to draw a picture first. Cool. It looks like this, however you draw your triangle. Boom. The boat's over here, again, whatever. It's attached like this. There's the boat. For Kayla, we'll put a sail on the boat. There it is, okay? And we know that the pulley's up here that's pulling in the rope, okay? And we know for some reason, this is the same as the other one, this is 10 feet higher than where it's attached to the boat. So this side of our right triangle over here is 10, and that's not changing. The other two sides are changing. So if we call this Z and this X, okay? Now, and the problem we did yesterday, it told us how fast it was reeling it in. This one gives us the information where we can find it, but it's a little bit of a pain in the butt. We know that the circular device, the pulley, whatever, it has a radius of 1 foot, and it's turning 1 revolution every pi seconds. Okay, that sounds complicated. But basically, as the thing goes around, as this thing rotates around and around and around and around, it's just pulling in rope the whole time. Okay, so what we need to do is use that information to figure out how much, if I can erase this. You can do it. Well, erase is not working.
Maybe you should keep hitting it as well.
Why don't you erase? No, you know what we'll do.
Yeah, why did you just do that from the beginning?
Man, I don't know. I'm not thinking. Okay, great.
Oh, it's raining harder. Can I go
Boom.
outside?
No, you cannot go outside. God take it. So as this thing rotates, as the thing rotates around, as we said, all we can do is find the circumference, because that's going to tell you how much rope gets pulled in every single time it rotates. So since it has a radius of 1, the circumference of that thing should be 2 pi r. And since the radius is 1, it's going to be 2 pi. That means every time it rotates, it pulls in 2 pi feet of rope. Okay? But we know that it rotates every single pi seconds.
So you divide it by pi.
Right? Yeah. So it's 2 pi feet every pi seconds. And that is just 2 feet per second. And that's the rate of change of what variable?
Of Z.
It's a rate of change of Z?
No, of Z.
Cool.
Of the pulley.
Of Z. Of Z. Now it's of Z. Thank you, Don. It's of Z, but it has to be negative because Z is getting smaller because it's pulling the rope in. Okay? Guys, in a typical problem, I'll just give you that. I'll say, hey, it's pulling it in 2 feet per second. All right? So hopefully at this point, you guys know how to handle this because we know how fast Z is changing, negative 2 feet per second, and we want to know how fast X is changing. So we said the way we do that is we set this up with an equation, and in this particular instance, it's going to be the Pythagorean theorem, and we're going to derive it. And when you derive it, you're going to get 2x dx dt equals 2z dz dt. Okay with that? Because the 100 goes away when it turns into 0. The derivative of 100 is 0 because 100 is not changing. Okay? And we want to know dx dt because the question's saying how fast is the boat moving along the water? All right? So that's how fast it's moving horizontally, so that's how fast x is changing. That's dx dt. And we know that z happens to be, there's 15 feet of rope out. So that's z. Z is 15 at this point in time. And we also know that dz dt is negative 2. So z is 15. dz dt, negative 2. We're not supposed to know dx dt yet. And x, we need to find. Because once we know x, then we can find dx dt. And we're going to find x by always going back up and looking at either the equation we've used so far or reading back through the problem to see if we can figure it out. But in this case, we know we have this. So we're going to use this equation to find x. We know that x squared plus 10 squared has to equal z squared, but z was what, 15? And 15 squared is 225. Okay, so x squared has to be 125, which means x is the square root of 125. And Joseph, you are absolutely correct. Okay, the negative 2 is dz dt. Okay, and we said that was negative 2 because this pulley up top of here is rotating, and every time it rotates, it pulls in 2 feet. Okay, it pulls in 2 pi feet, but it rotates every pi seconds. So it was pulling in 2 feet per second. Okay, it's negative because z is getting smaller. If the boat was going out, it would be positive too. Okay, the 15 came from the problem. It says there are 15 feet of rope out, and z is the rope in this case. All right. So we're going to put in x is 5 root 5. And then dx dt, when you solve this out, is negative 60 divided by 10 root 5. And to simplify that down, you're going to get negative 6 over root 5. And just to rationalize it for fun, it's negative 6 root 5 over 5. And that's also going to be in feet per second because that's what z was in.